Hi, everyone. Welcome back to WDL. We're having our first workshop of the World Data League. I'm here with Pedro Sarmento. He's a Chief Research Officer at Nova Cidade Urban Analytics Lab. Pedro holds a PhD in Information Management in Geographic Information Systems by Nova Information Management School. And he previously obtained a master's in science and geographic information systems by this same institution. Currently, he's a researcher at Nova Cidade, and he's analyzing spatial data and managing projects that explore the potential of data science and GIS to promote social, economic, and environmental well-being at city, regional, and national level. So it's not much of a surprise, the workshop that Pedro is doing here today with us. It's exactly about geographic information systems, concepts, and spatial data analysis for data science. In this workshop, the purpose is to fill in the gap in the use of spatial data by data scientists. The workshop will cover the main concepts of geographic information systems and science, essential to understand spatial data and how to integrate and analyze it in a data science project. Types and characteristics of spatial data and essential geoprocessing operations will be highlighted in this workshop. And also we will have a demonstration in the end where a case study of a city will be showcased to demonstrate some of the concepts that Pedro will talk about during this workshop. Pedro, I will pass the mic on to you. For everyone participating, the Q&A will be very much similar to what we did on Saturday. So you guys can use the chat to, post messages, motivate Pedro, criticize your terrible host, whatever you want to do. And then you can use the Q&A to post questions. And you can also upvote questions from your fellow participants if you want to see that question being asked. And a little twist that we have compared to Saturday is the raised hands. So you can actually use this function to notify that you want to come in to the stream. And we will do a little mix of Q&A and raised hands, and I will bring people to the stream and pose questions when we're at the Q&A phase. Okay, Pedro, the mic is yours. Good luck, everyone. Enjoy.
Okay, thank you, Miguel. First of all, thank you for all to attend this workshop. It is a very pleasure to have you in this workshop, and resume briefly the workshop. What I will present is mainly my operations that I usually use when I am working as a GIS analyst in the projects of the lab where I'm making my research. Okay, so I will share my screen now. I think you will always see the screen. Okay. So as I say, the workshop will cover the main concepts of geographic information systems information and also the spatial data analysis and the main concepts that I think are essential to integrate, are essential to understand in order to integrate them in data science projects. Okay. So in summary, in the beginning, I'll make a question: what is GIS? Then I'll give some historical aspects of GIS. I briefly explore the characteristics of spatial data. I also highlight data models in GIS, and then some geoprocessing operations in the end. And finally, a demonstration of a 15-minute city case study, in this case for Lisbon, and also an hotspot analysis for cultural events in Lisbon, to highlight and to show you some of the operations and some of the operations that I will present you during the presentation. So what is a GIS? It's a class of information that keeps track not only of events, activities, and things, but also of where these events, activities, and things happen or exist. In this case, GIS into the keyword, the major word is where things are happening. It can be seen also to manage information about geographic places, analyze spatial relationships, and model spatial processes. Also provides a framework for gathering and organizing spatial data and related information so that it can be displayed and analyzed. GIS is widely used for a very wide range of purposes. For example, an urban planner might want to assess the extent of urban fringe growth in each city and quantify population growth. A biologist might be interested in the impact of slash and burn practices on the populations of amphibian species. A natural hazard analyst might look to identify the high-risk areas of annual monsoon-related flooding. Other things, a mining engineer could be interested in determining which prospective copper mines should be selected for future exploration. A geoinformatics engineer hired by a telecommunications company may want to determine the best sites for the company's relay stations. Or a forest manager might want to optimize timber production using data on soil and current trees distribution. And also, a tourism planner may be interested to investigate where is the best place to build an hotel. Basically, some of the things that with the use of GIS we try to resolve are very similar to the ones that are also present in data science projects. So, talking about some historical aspects, GIS is associated as cartography history and with the first attempts to represent graphical space. It is also indissociable of humanity history, where maps assumed Wallis' fundamental role in the process of spatial knowledge, production, and an adequate language to their communication. So here is an example, a battle in a petroglyph. Here is represented a village where we can see the roads and houses. Also in Micronesia, navigation maps from the 19th century. Here is a representation of Napoleon's campaign in Russia. For example, in the width of this red bar represents the quantity of soldiers that enter in Russia in the Napoleon invasions, and the black bar represents the width of the black bar represents the soldiers that retreat from Russia, and as you can see, along the way they lost a lot of men, and this is all also related with this graphic below that represents the temperatures that occurred during the time of the retreat of the Napoleon soldiers. As you can see, it's very interesting, this map. Also, another interesting map that is sometimes showed as a good example of the beginning of the GIS is this map of John Snow of outbreak of cholera in the city of London, where he mapped the deaths, the people that died in London, and also make a relation with the pumps where the water was contaminated, and in this way he could relate the number of deaths and the source of water that was contaminated, and somehow control the outbreak of cholera in the city of London. Talking about the main characteristics of geographic information. The first law of geography from Aldo Tolber, 1970. Everything is related to everything else, but near things are more related than distant things. There is also another dimension that should be included also in this sentence, that is time. For example, We can have two events that are closer in space, but they could be farther away in time. For example, one thing could happen almost in the same place about 100 years ago, is not so related, is just related in space, not in time. So time is also another important thing to have into account is in this first law of geography that is from 1970. Other characteristic of geographic information is the Fractals Principle, a repeated geometric pattern at progressively smaller scales which produce irregular shapes and surfaces. As you can see on the map on the left, we have a scale of 100 kilometers, and the length of the Great Britain Island is 200,800 kilometers. Going for the right, as you can see, the scale is increasing, and the length increases a lot, tending to infinity. And this is a characteristic of geographic information, of spatial information that we have to take into account, namely for in the cases where we want to aggregate data in a certain spatial scale. This will affect massively the outputs of your models. If the scale of analysis that will aggregate your data will have a great impact in the outputs of your models. So it's an important thing to retain about the spatial information. Another thing is uncertainty of geographic information. In this image, you can see the polygons drawn by a photo interpreter, but many times these borders are not clear because spatial information is vague and uncertain due to their natural continuum, mainly principle, the environmental variables like land cover, for example, where sometimes it's very hard to distinguish when it starts a forest or when it ends a forest. So geographic information could be uncertain, and also this uncertainty can propagate along your models. Regarding data models in GIS, we have two types, vector and raster. Regarding vector data models, three types exist that can be point lines or polygons, are represented by XY coordinates, and also the information about features are called attributes and are stored in a table. And generally is useful to represent discrete data, for example, streets, rivers, and administrative boundaries. The other data models, the other data model that is also used is the raster model. Data is represented as a surface model by a matrix of values, pixels, and is useful to represent continuous data. For example, reflectance in satellite imagery can be used to predict land cover classes in a certain area, elevation, slope, aspect, or population. In this image, you can see a representation of the real world in both data models, in raster format on your left, where each pixel has one feature of the real world, for example, the river and the forest, and also the house. And on the right, you have the same representation of the real world, but in the vector format. For example, the river is represented as a line, the forest is represented as a polygon, and the house as a point. Here you can see another example of point features as represented as vectors and also as raster on the right. Line features as vector and rasters, and polygon feature as polygon and rasters. In this image on your right, you can see this road represented using several points, and this is also an example of the Fractals Principle that I was talking previously. As you can see, when we have 7 points and we go to 21 points, the roads are much more delineated than we're using less points when you use more points. Okay, and this is very important because this will change the could change the outputs and influence the outputs of your model. So in sum, reality is modeled as a collection of vector and raster layers. So now I want to go to menti.com and insert this code 66025622. Okay, I will present and answer this question. Which GIS data models do you know? Please go to menti.com and insert the code above. And respond to the question to see which GIS data models do you know. It's very simple. Just write in the browser menti.com and use the above code 66025622. Okay. Good sign, you are not sleeping, okay. Just a few more moments. Okay. Okay, in general, you answered the right question. Vector and raster are the GIS data models that are generally used in geographic information systems. I will pass again to the presentation. So I'll talk now a little bit about geoprocessing operations. So geoprocessing is a framework and a set of tools for processing geographic and related data. To project data, we have also overlay operations, aggregation operations, proximity analysis, and spatial analysis. In the beginning, I like always to start with this one, with project data. Because sometimes this aspect that I will talk about is somehow renegade for a second plan. Is not very well mentioned when we talk about spatial data, and it's very important because we can represent spatial data using a geographic coordinate system where the data is located on the Earth's surface. The locations are stored in degrees, and as you can see in the right image, in the left image on your right, and also as a projected coordinate system that draws the data on a flat surface that are located, and the locations are stored in meters. And when you project your data and when you pass from this geographic coordinate system to a projected coordinate system, there are some characteristics of the spatial data that are transformed. Some transformations preserve, for example, area, others not, and you have to take into account when the initial data that you have, and have notion that the data that you have is in a specific coordinate system, and you have to understand the implications of those coordinate system in the measures that you are trying to retrieve from your data. Okay. This is very important. In this World Data League, as we are making challenges at city level, I would say that a project coordinate system should represent better the analysis that you will try to make during the World Data League. Okay, I think it's very important, and also to, for example, if you want to measure the distance between 2 points, if you do it with a geographic coordinate system, you will do it in angular units and not in meters. So it's very important to you to have into account these characteristics of the coordinate system of the data that you are receiving to do the challenges. Okay, this is very important. An operation clip extracts input features that overlay the clip features. For example, you can use this tool to define the region of interest, where you have an input data, you have a clip feature, and using true clipping, you can retrieve only the data that you want for a certain study area, for example. You have also the intersect that computes a geometric intersection of the input features. Features or portions of features that overlap in all layers of features classes will be written to the output feature class. For example, in this example, we have a squared input and a circular input, and the output is only the area where both feature classes intersect. You have the union that computes the union between the two data sets. You have here this is also an important one, the spatial join, that joins attributes from one feature to another based on the spatial relationship between both features. For example, if you have a map, for example, of land cover, and you have a certain event in the format of point, through their location, you can extract the attribute of the land cover and associate it with that event in particular. Okay, and this could be very useful so you can enrich your data sets to do the analysis during the World Data League. This is very, very important. Another important, this is not exactly an aggregation operation, but I included in this part, that is the spatial grids. Through tessellation, you can create a tessellation grid that could have very many formats. Could be hexagons, squares, diamonds, triangles, and this is the grid where you can, for example, aggregate your data. And as I was saying previously, in the Fractals Principle, the size of this grid, the extent of each cell, will impact also your models. Okay, this will impact your models. Characteristics of these grids. For example, the square grid is useful if you want, for example, to make a study at several scales, for example, where you can aggregate squares and have and summarize the attributes, the features inside these squares, and make an analysis at different spatial scales. And for example, you have hexagons that you can use, for example, that are generally used to model movement, because hexagons have a similar shape as circular, and you can go in 6 different directions. Okay, when squares, you can just go in 4 directions, and it's better for model to model phenomena that have movement in space. For example, in this map on your right, it is a grid of hexagons, and we have aggregated to each hexagon the number of bikes in each hexagon. Okay, and as you can see, as we are trying to model movement, we have more directions where data could be aggregated along the hexagon cells. Another operation is the dissolve that gets features based on specified attributes. You can see this aggregation operation as a group by, but not only of the tabular information, but also of the geometry. As you can see, for example, you can input of counties, and you want to aggregate all your numeric variable on a district level. So you can dissolve these counties by the code of the district and have a summarized value for the district. We have also merge, where you can combine two data sets. For example, you could have two parts of roads that are separate. You can merge it together to combine them. Could be useful for that. One of the most important is this one, that is aggregate points, where you aggregate your events. That could be, for example, the incidence of criminality in a certain area, the number of cultural events in a certain area. You may want to aggregate this to a grid, like the ones I showed you previously, or to a set of polygons. And besides the importance to aggregate this in a spatial frame, you may want also to aggregate this by time. Okay, that is the example below, where we have a three-dimensional, where in XY coordinates you have space, and then in the third dimension you have time. And for a specific time, for example, you want to aggregate for an hour the cultural events that occur in a specific location, and you construct a spatial time data frame where in each entry we will have a location and the respective timestamp, and also all the variables that you use in modeling. Okay, and this is very important, so you can construct if you want to model time and space in your project. You have also summarized within. In this case, is also an aggregation operation where, for example, we could have a set of polygons, and imagine that we want to measure the length of the roads that falls within the specific polygon. If through a summarize within, you can in each polygon summarize the length of roads, of the length of cycle lanes, for example, in each polygon. You can do the same for points or also for polygons, for the intersection of polygons. Another one that is important in talking now about proximity analysis. We have buffers that be applied to points, to lines, or to polygons, and creates buffers around input features to a specified distance. For example, if you want I want to understand what is happening until 10 meters of a road, or until 500 meters of a certain point, because I want to aggregate certain type of data to a specific point in space that I want to model. Okay, this is also very important to assess. Another important one for proximity analysis is the near function, where, for example, imagine that you have a road and you have a traffic accident, for example, but you don't have the address of the traffic accidents. You can, through the near function, you can associate to each traffic accident a specific road, and then you can summarize for a specific road the number of traffic accidents that occurred, for example, in a certain street. Okay, this is could be very useful in the case where you don't have a key that you can use to join, for example, a road or an incident, for example. You can also construct artificial surfaces when you have a set of points, for example, through Thyssen polygons that contain only a single point input feature. Any location within a Thyssen polygon is closer to its associated point than to any other point input feature. For example, you can want, for example, for a specific point, aggregate other spatial characteristics that are near the point. You can, for example, create this tessellation through Thyssen polygons and aggregate at each polygon that corresponds to each point all the other variables that you are trying to model, and to have your master table ready for modeling. Talking about a little bit now about spatial statistics, an important aspect is spatial autocorrelation because of that property that the Tobler's law, the first law of geography, that near things are more related than things that are more farther away. You can use, for example, the global more-on-one statistic that measures spatial autocorrelation based on feature locations and attributes. You can evaluate if the pattern is expressed as cluster dispersed or random. Another global measure that you can use is the GETIS or general G, that measures the degree of clustering for either high or low values. And you have also measures for spatial clustering. For example, the GETIS or GI star identifies statistically significant spatial clusters of high values hotspots and low values cold spots. And this, for example, could be used instead of you using, for example, k-means for clustering. You can use this type of clustering, so you can cluster your data and try to understand if there is any pattern in the independent variable, if it can be explained or more explained using these clusters. Another measure that you can use is the Ansling local Moran statistic that identifies statistically significant hotspots, cold spots, and also spatial outliers. This is the same say that, for example, in a hotspot, it can identify specific points that are cold spots inside an hotspot. That could be interesting, for example, for your analysis. Some examples of the applications and libraries for spatial analysis. You have the ArcGIS Pro, that is a commercial software. You have the Quantum GIS, that is an open source software. For Python, you have GeoPandas. You have PyCell, that is a spatial analysis library. NetworkX, that is a library for network analysis in Python. And you also can use R for this type of spatial analysis. I want now to ask you to go also again to menti.com. And use the code 66025622. And I want to ask you to choose a geoprocessing operation that you think it could be useful for a data science project, for example. Okay. Indeed, the ones that you are choosing are very similar to the ones that you already use in data science projects, because it's for example, the summarize within is some kind of group by, but where you can use location, and the spatial join also the same, and especially the spatial join where you don't have, for example, a key to link the two types of information, you can use the location to link both data sets, and this could be very useful for your data science projects. Okay. Okay, thank you very much. I will go now to. Okay, and before we go to the demonstration, I want to know if you have any question regarding what was showed.
Pedro, I was looking through the Q&A. We don't have any questions from the audience. So, guys, if you want to ask questions, you still have time. Right after this, Pedro will do the demo. So it will be a little bit different, and the content will be more applicable. So if you have some questions, don't be shy. Now it's the time. Okay, we have a question. Pedro, the question is vector data model and raster data model. When to use each one? Any specific examples?
For example, in general terms, the vector data is more used to represent discrete data, but you can have also, for example, in the attribute table, you can add several variables, continuous variables that you can represent in bins. For example, in raster, for each pixel, you could have a continuous variable, for example, where you can represent the slope of a region, for example. Or, for example, in remote sensing, a satellite image is each band is a raster image where in each pixel you will have a value of reflectance that you can use, for example, to predict land cover, for example. But in general, the raster format is generally used to model continuous variables, and the vector data model is used to represent discrete characteristics of space. Okay, that is the general idea. But in some cases you can, for example, you can codify. For example, if you want to make classes of slope, you can reclassify your data for example, in classes in bins, for example, from 1 to 5, representing each number a certain bin of slope, and you can discretize your raster data representing deep classes. Okay, so but in general, raster for continuous variables and vector for discrete variables.
Okay, we just got another question from Sarah. The question goes, maybe you are going to address this on the demo, but I'm interested in understanding the differences between the several GIS tools you mentioned, especially the Python ones. For instance, what are they designed to be used for?
Okay. So I don't know if I really understand the question, because the tools, the name of the tools could not be exactly like the names that they give in Python, the names. Okay, so the names that I gave are based on the software that I use, but I tried not to stick with those names. Okay, but I try to explain what the tool do, but because it could have certain nuances that are different from application to application. Okay, so my main preoccupation here is try to understand what are the type of aggregations that can be using spatial data in the context of data science. Okay, but maybe during the demonstration you will have a more clear vision of what I'm trying to say.
Okay, cool. Yeah, I was going to ask Pedro from the libraries and the frameworks that you showed before. Which ones were for Python? I don't know if you specify that, because I know that we have a lot of participants that are going to use Python to develop their.
Okay, you can use GeoPandas, okay, PySal and the Network X from these examples that are here.
Okay. Okay, so hopefully that's useful for you guys out there that prefer to program in Python. If you want to use GIS, you have these 3 good examples from Pedro. I'll wait a little bit more to see if we have more questions coming. Otherwise, Pedro, I think we can go.
Okay.
We can proceed to demo.
Okay, so to give you a little overview of the demo that I prepared. I don't know if you already heard about the concept of a 15-minute city that may be defined as an ideal geography where most human needs and many desires are located within a travel distance of 15 minutes. And in the example that I will show you, in Lisbon, we will assess which parishes are closer of this concept regarding pharmacies, parks, supermarkets, and also bike stations, and also make a comparison with the results achieved with the price of real estate. So I will go here to the application. Okay. Here you have a map of the parishes. Okay, in Lisbon, 24 parishes, and we want to know from these parishes, taking into account the concept of a 15-minute city, if they are more closer or not of this concept of the 15-minute cities regarding supermarkets, bike stations, parks, and pharmacies. We have, for example, the location of pharmacies, the location of parks, bike stations, and also supermarkets, okay? And we want to assess from in each one of these parishes if they are closer or not of these services that I showed you, okay? Well, but the parishes, some are big, and we want to know exactly, to have a more correct view, is to try to have an idea where the main buildings are, okay? And we have a map here of the buildings in Lisbon. For example, these purple areas represent the buildings in Lisbon, okay? So I have the buildings and I have the parishes, and I want to, for example, I want to associate to each one of these buildings areas the respective parish, and to do so, I will do an intersect, okay? Where I will choose the buildings areas and my parishes. I will leave that name, okay? I want to have all the attributes. I will run. And we now have our buildings intersect with the parishes. We have our buildings here, okay? And we have our parishes inside in each polygon that was intersected with the buildings, okay? But what happens now is that for example, for a certain parish, you will have, you could have more than one polygon. So we want to dissolve this in just one polygon of building areas for each parish, okay? In order to have 24 areas of buildings for Lisbon, as now we have 295 polygons that resulted from the intersection of the buildings and the parishes, okay? So I will dissolve this. I will use this as input feature. And I want to solve my dcof, that is the code of the parish, and I want also the name of the parish. Okay. For example, if you have a numeric variable that you want to aggregate, you can also choose here, and you have a series of statistics type that you can aggregate. As I was saying previously, this is very similar to a group by, but in this case, besides the variable that we may pretend to aggregate, we are also aggregating the geometry of the polygons. Okay. Right here, dissolve. Now, as you can see, we have our building areas representing for each parish, okay? Each row is a parish, is representing the area of buildings in each parish. So now we have the building areas for each parish, and we want to create, to have an idea from the locations where it be accounted the services that we want to assess. Okay. For this purpose, I will compute the centroid of these areas. So, and those centroids will represent the distance from where I want to measure the accessibility of the services that I mentioned. Okay. So I will create the centroids based on this. And I want to force the point to be inside the polygon, okay? Because the format of the polygons, the centroid could not be exactly inside inside the polygon, so I will force to be inside the polygon, okay? Now I have the centroids of each parish, of the buildings in each parish, and is from this point that I want to make my 15 minutes areas. Okay, I know from the literature that a 15-minute walk, the citizen can walk about 1,200 meters. Okay, the literature is this value that they report. So I will create buffers from each one of these points of 1,200 meters. I will include here the centroids. I will choose meters, 1,200 meters. And one thing that I mentioned previously is if you have the data in a geographic coordinate system, you cannot use the planar method. So you can use this distance because the distances are measured in chordal units. Okay. I will not dissolve the buffers of for each one of the centroids. So now we have our 15-minute areas. Representing the areas where a citizen can achieve in 15 minutes. And now, in each one of these areas, I want to assess the accessibility to each to these services that I highlight now. Okay. To do so, you will aggregate to each one of these buffers, to each one of these 15-minute areas. We will aggregate all these variables. I have already this data pre-processed here, where for each one of these 15-minute areas corresponding to each parish, I have the count of pharmacies, the count of parks, the count of bike stations, and count of supermarkets. Okay. So I will run here a k-means analysis to create some clusters regarding these variables. Sorry. I will choose the numeric fields that I want to compute the k-means, and I will choose to create 4 clusters. Okay. We have now our clusters created. And as you can see, we have cluster 2 that is more that has higher values of these services when compared, for example, with the blue one. Okay, that are in the periphery of the city. The periphery of the city, the access up to these services is not so much well defined as for the interior of the city. Okay. Just remember, cluster 2 was the one that presented the higher values when compared with the other ones. Now, I want to add this. Now I have here my housing prices. And for each quarter, I have the price of the houses. And I want to see for each one of these clusters, what is the price of the houses in these clusters, okay? I have my buildings areas here, and I will join based on the DCOF. Based on DCOF, that is the code of the houses, I will validate the join to see if everything is okay. Okay, you will join 1,121 records. just for you to see what happened. I have now the price of the house for each parish during the time period of the real estate prices that we had access, that is from 2007 to 2020. Now I have to associate now these clusters to these building areas. And to do so, I have first to create a join in the building areas buffer with the object ID and also with this k-means with my source ID. Okay, I will validate the join. Okay. Now I have for each buffer I have my cluster ID, okay? And finally, I have to associate to my buildings the clusters, okay? Now I have in my attribute table, I have the clusters IDs, okay? I will change the symbology so you can have a better notion of this. So it's cluster 1, 2, 3, and 4, okay? And now, as I said previously, cluster 2 presented the highest values for the highest values taking into account a 15-minute city, okay? And I will create a chart where I will choose my cluster ID. I will choose the mean from my price in square meters, and I want to split it by cluster ID. No, sorry, year date. Okay. So as you can see, cluster 2, as you remember, is the one that was above average regarding those services that we are analyzing. And also during the time period is the one that is also presenting higher values of real estate, okay? Let's see for the blue one that is below average. It's here in the middle, okay? So this is an example of an analysis that you can make regarding using spatial data and several operations, geoprocessing operations to deal with spatial data. It's kind of analysis that you can make, okay? And with this analysis, for example, you can see if the price of real estate is adequate to the services that are available for a certain area of the city, for example, okay? I prepared also another another presentation that is regarding events to check the spatial autocorrelation and make an hotspots analysis. What you are seeing are cultural events in Lisbon, okay? And we want to see if there is any relation and create areas of hotspots of cultural events in Lisbon, okay? We have an hexagon grid. This grid has each cell has an area of 3 hectares. That is medium size of a census block in Lisbon. And the idea is we have to aggregate these events to each hexagon. I have already preprocessed that. And here you have a map for Lisbon where in each hexagon you will have the count of events. Making a visual analysis, you can observe that is some kind of pattern here in the center, and also some here. I will now run the incremental autocorrelation. That is basically, I will run the global more1 statistic for a series of distances to check if there is some check in which distance there is some kind of spatial autocorrelation in the data. And this is useful for what? For example, if you want to run an hotspot analysis, you have to define a distance where this spatial clustering is happening. So if you run this incremental autocorrelation, is the same to say the global Moran statistic for a series of distances, you can check in which distance the spatial clustering is occurring, okay? So I will put here our events. Our variable is the count of events. I will choose the distance bands from 15. And my beginning distance will be 372 meters. Why? I will test this. As you can see, is the distance between two hexagons, okay? I'll choose this starting distance with increments of 186 meters. That is the distance from the neighborhood hexagon, okay? This will make 15 times, starting in 372 meters, it will increment 15 times 186 meters, okay? We'll create a report. Is running the global Moran statistic at all distance that we specified. I will show you. So, as you can see, there is a peak here. 1,674 meters. There is a peak here where the z-score reaches its maximum, saying that is the spatial clustering is maximum here, okay? And we can use this distance to run an hotspot analysis. where I will choose my events. I will choose a distance band, and I will insert the distance where the spatial clustering is happening, okay? And you will compute the hotspots using the Getis or Raster algorithm, okay? I will run the analysis. And you can see here is the hotspots and cold spots regarding the events in the city of Lisbon, depending on the degree of confidence, depending on the significance of the variable in each one of these areas. I will show you the table of attributes of this. You will have a z-score. Where the z-score is maximum, it will be assigned to bin 3 with 99% of confidence, because we have a z-score of 28, and we have the opposite when we have our z-scores negatives. Okay. You have also the p-values in each one of the hexagons. This could be useful, for example, for you cluster your data sets, taking into account the spatial relation between the variable that you are trying to model. Okay, there you can add the space variable in ways. There are more simple ways. For example, for a bus station, you may want to include, instead of the counting of for example, of micromobility of bike stations in a certain area, you can use, for example, the distance to those, or the nearest distance to those bike stations. Okay, instead of using that happens in a certain specific area. And you can use this to enrich your data set, as you can use also these scores also to enrich your data set and check if this could be a useful variable or not for the modeling in analysis. Okay, and you have also these clusters that you can use to aggregate your data and to make a final analysis, taking into account the probability that a certain event occur in a certain place or not. Okay. So this is what I have to show you. If you have any questions, I guess.
Pedro, thank you so much for the time. You have do you have a little bit more time to do a quick round of Q&A? Pedro, can you hear me?
Yes.
Yeah. Okay. So we just have a couple more questions. Before I go to the questions, let me just remind everyone who's tuned in that you can use the option raised hands if you want to jump onto the stage with me and Pedro, and you can ask a question directly with or without video, your choice. So that option is up there next to Q&A, and I'll receive a notification. I can let you in. Okay, let's take the questions now. So we have a question that has a lot of upvotes from Nicholas, which is, do we have access to such visualization software? So I can take the question, Nicholas, from WDL. We don't have an official license to give to participants to use this option, but you have a 21-day free trial for the software that Pedro was using, and that's it for you to at least complete this stage. So the name of the software, Pedro, correct me if I'm wrong, but I think it's ArcGIS Pro.
Sí. Yes.
So quick Google search and you'll get the website, and you can use it for 21 days for free, the pro version.
Yeah, just one comment that you can try to replicate if you are more used to Python. For example, you can try to replicate these visuals in Python, for example. Okay. I don't know if it's better or not, but I think it's another option, so you can choose. Okay.
Okay, cool. I'm getting some thumbs up, so I guess that's a good option for everyone. Another question we got was if this data, Pedro, that you were using, if the data is public.
The location of the services is public. Is information from the Lisbon Open Data Portal. You have a lot of information there. If you want to use and make a study for Lisbon, go ahead. It will be very interesting, and I'll be very pleased. The data from real estate is not public, okay? But you have also data from real estate from Statistics Portugal regarding the median prices of real estate. Okay, but the data that has been used for the buildings, for example, it was from the Directorate General of Territorial Development of Portugal. That is the entity responsible for the land cover, for the production of land cover maps for Portugal. It was retrieved from there, and also the map of the fishes also from the Directorate General for Territorial Development. Okay, also.
Pedro, can you repeat the name, because we're
yeah, I can write in the chat.
Yeah, go ahead, that'd be perfect.
I'll insert here the link. It's very fast. Just a moment.
The website is going to start receiving a lot of requests, and people will start doing why. It all came from this workshop.
Okay, now it's better.
Okay. I was trying to access the websites to see if they're...
Yeah, I think the problem, I think they don't have the English versions.
For the second one, there you can select language in the footer. So if you scroll down to the bottom, you can change language.
Okay.
For the first one, I couldn't find anything.
Yes, the other I think don't have.
Well, but hopefully you can download a tabular data set or something that you can quickly just have to translate the column names. Hopefully that shouldn't be very complicated to access. But yeah, it's reality of data. It is what it is. And we have another question from Ishan. The question goes, do the overlay operations work with the aggregated points as well?
The overlay...
This is a question maybe from halfway through the theoretical part. I don't know if this... There's some extra information going, the 3D structure with time as a third dimension. Can it be traversed using these operations? So,
sorry, Miguel, I didn't understood.
So I'll just read the whole question. The whole question goes like, do the overlay operations work with the aggregated as well? The 3D structure with time as a third dimension. Can it be traversed using these operations? So I think this is referring to the join operations that you showed before.
Yes, you can, for example, create, for example, in ArcGIS, you can, in aggregate points, you have an option where you can aggregate also by time. Okay, and also you can you create. There are other options that you can create a cube, where, for example, what will happen is it will divide your study area in squares or other other polygon, and you'll aggregate for example your data. If you have a date, you just have to have a location, a timestamp, and a specific variable. It will aggregate your data accordingly with each bin and the time it represents. Okay, for location 1, timestamp 1, I will have an aggregated value of X. Bin 1, timestamp 2, the same thing for all bins and for all timestamps. And this is also very, very useful if you want to model in time and space, because it's a way to create a space-time frame that where you have your aggregated values along time and space. Okay, and this could be very, very useful for modeling purposes, where you, for example, instead of predicting where something will happen, you can now answer when and where it will happen. Okay, and this is it could be very important to have maybe a better model. Obviously, it depends on the objective, but you can answer to more questions if you have the also time. If you have space and time, you can answer to much more questions if just you have space. Example.
Okay. I was trying to see if we get some last-minute questions from the audience. Okay, I just got another one. Is WDL expecting a similar kind of GIS analysis that Pedro presented and summary for the final solution proposal? Not necessarily, not necessarily. So this all depends on your approach to the challenge. How much visualization do you want to? I mean, this is really up to you. There are no expectations in terms of how you do your analysis, what you output. The purpose of doing this workshop was more towards giving you another option, giving you more things to consider when you're doing your analysis. Okay, there's no expectation of GIS mandatorily. Okay, sorry, Pedro, but this one I think was more WDL related.
No, but I totally agree, because this is just to give you more ideas so you can work on in your projects. Okay, that's the main idea. They are not mandatory.
Completely. Okay, I don't think we have any more questions. There also no one that wants to join us on stage, Pedro, unfortunately. So it's just you and me today.
Okay.
So before I say my goodbyes and my thank yous, I just want to inform everyone that this session is being recorded. It will be made available to all of us. If you missed some part of it, or if someone from your team missed a part of it, this will all be made available. And as usual, everything will be communicated to you through Discord. So I see some people clapping hands. That's cool. Yeah, so just to wrap up, for the rest of the week, that we won't have any more live events. So everything will be happening on Discord. The activities are happening. The next deadline that you have is this Saturday for the team checkpoint, which marks halfway through stage 1. More information about that will be shared on Discord. Okay. And just to give my enormous thank you, Pedro, for this an hour and 21 minutes that you stayed here with us, teaching me and the rest of the participants from WDL a little bit more about GIS. Hopefully, this was insightful and interesting to everyone. And yeah, just thank you very much, Pedro. I don't know if you want to have some last words.
Yes, I want also to thank you all to attend, and also for the idea to have this workshop, because this is something that sometimes is missing in some research teams, because there's some kind of a gap between these people from GIS and from data science. And I think it could be very useful to enrich your data science projects and have this notion of space in your analysis, as nowadays and much more in the last years. A lot of data have now a spatial location, and it's very, very important, so you can integrate this data also in data science projects. And I think it's very, very useful for not only for the World Data League, I think, because as we saying, this year's event is related with cities, so we will have a very, very focus on location. And I hope at least that you can retrieve some ideas and help you in the construction of more refined data sets, so you can model better and consequently have better results. Okay.
Awesome. Pedro, thank you so much for those last words. I'm just getting, okay, I just got a new piece of information from my team. Okay, Leon is joining us. Leon, are you there?
Yeah, just 1 second. I think, okay, video. There we go.
We have some cool announcements.
Yeah, we had a really last minute announcement to make, and it's actually concerning about this workshop. So Pedro, first, again, also from my side, thank you for this workshop. It was a really nice introduction. And actually, we have another workshop to announce, an extra one, which will happen next week on Monday at the same time. And it's going to be also regarding analyzing geographic data, but it's going to be a bit more hands-on. It's going to be by Nikolai Yanakiev. He's from Austria, and he's going to do a workshop on OpenStreetMap. So basically, how can you mine the data in OpenStreetMap, and how can you get all the data that there is in there? It's one of the biggest open coverage street network data set as well. So there's a lot of things you can extract there. And the focus of the workshop will be basically on all this rich information you can extract for them, and also how can you look into the relationships. He will show you practical examples in Python and how to visualize them as well. And then he will also make these available. And starting from next week, also be able to answer some questions that you might have as well on our Discord. So we just got this confirmation around 10 minutes ago. So I think that's really good news. So I just want to share with you guys, and we'll announce it as well in a bit on Discord.
Awesome. Leon, thanks for that piece of information. I was wondering if somebody was jumping onto the stage with us or not, and I'm happy you did.
Yeah.
Okay, to everyone else, see you on Discord. Pedro, thank you very much again.
Okay, thank you also.
And we'll see each other around. Bye, guys.
Bye. Good luck.